this is my first half. First of all, my name is Amir. I had the graduate studies in TAP, in the Technical Economic Systems program, and also had the Civil Environmental and Agricultural Robotics lab. So I will talk a bit about the task research day, and then move to some research in my lab, and then come back to the research day. So that will be about 10 minutes. I take a bit more because I have these two hats. Then we'll have six professors talking about their lab. That will take about an hour plus. And then we'll go outside. We already started mingling around the posters. We have 10 excellent posters outside. And I'll show you at the end here. We all are the referees and judges for the best posters. Okay. We will pick three best posters, and they will represent the program in the Techno-Wide Research Day next month. Okay. So don't forget to vote. Everybody can cast their vote. But before that, so this will be the first part in the posters. I don't know exact hours, but more or less until 5, but less than that. And then we'll do posters about half an hour. And then after that, we'll see who got the most. So this is how the 2024 website looked like. We uploaded all talks, and also last year, and this year we'll have again the talks. Okay, so now I'm switching hats to my research. So I always contemplate if I want to talk about past research, current research, current projects for new students. I'll do a bit of mix, but mostly very shortly I'll introduce what we kind of do, what we did in the past, and what are the open questions we're dealing with right now. And in a way, I'm kind of giving you a few teasers to posters that students will present outside of school. So my lab is called the Civil, Environmental, and Agricultural Robotics Lab. Although I work on different aspects in these, but these are the three applications we mostly work on. For instance, in the civil applications, one task work by an C student was related to the built environment. While building high-story building, we developed algorithm to not only map and localize. In 3D, we also asked the question, what is the progress of the building environment? So we know we have the process that the building should be built. So one wall before the other, or one floor, of course, before the other, but other aspects and other geometries. That in this case, the UAV would not only localize itself in 3D, will also localize itself in time and understand where it is in the process and give update to the people in the offices of understanding what happened during the process. So this is a typical or one example of a project related to civil. I will talk a bit more about outside work, about earth moving. We had some search and rescue related work. We had stuff related to augmented reality, of actually projecting on the floor or on the walls some CAD or BIM models to the workers instead of measuring. That was a project in the past. Recently, a PhD student graduated, worked on in environmental aspects, worked on understanding where, as you can see, these are GPT images from 2 years ago. They're pretty bad. Today it looks better. I didn't update that. Anyway, looking first of where, for instance, hazardous plumes are in the air, or where oil spills are, and we have some different coverage algorithms to understand where to go to sense, and also where to go to clean the oil spills. Yanai will present something somehow related to this, related to forest fire monitoring, and to understand what should the plan be before a fire starts, in order to have the highest reward to actually check the places to see if a fire started. But that was not clear, and I will explain it a bit better. And this is the environmental aspects. Agriculture aspects, we have quite a few projects in the past. We worked on navigating inside orchards related to manipulators for harvesting. Recently, we have an idea. It's a student who's not in this program, but actually in our department, working on inflatable mass harvesting. So we have other purely mechanical aspects of agriculture, not just algorithms. We have quite a few of ground robots or field robots. This is a family photo from a while back. We have quite a few new ones, and we discontinued using some of these. We like to work with real robots, not only in simulation, we simulate them, and we also recently started being lazy and started using manipulators to mimic the robots in order to do more sophisticated learning and so on. We needed a lot more experiments, so we're mimicking the way that the rovers are actually moving using similar constraints on mobile manipulators. I'll talk a bit about that in a few slides. I'll actually skip this older work, and I'll move to some of the projects we've been working on in a few years. And 3 students are working on this project. 2 of them are presenting posters today. So the idea is this is not our work. This is work related to dry stone construction. Looking at these boulders, how do you move them from place to place in order to build a small dry wall or different construction? Think about just earth moving or rock moving. The way they decided to do this is by pick and place. We're used to having a pick and place in robotics. They built an amazing, really big robot that picks and places these boulders. Our idea is not to do what is called prehensile manipulation by actually doing some grasp and moving the object from place to place, but actually moving to non-prehensile, pushing them, doing push manipulation while not controlling all these rocks in full certainty. So looking at this cartoon that Federico started drawing for us, let's say you have a rover, or maybe even a few of these rovers. Let's say you have a bunch of aggregates, rocks, small or larger ones like we saw before. And let's say for now, let's talk about a simple task. You can think of a task of clearing these rocks away or a task of putting all these rocks inside a specific zone or a set, this shape here. What should the planning algorithm be in order to do this correctly? Now, remember that when we push these aggregates, we don't know exactly where they are. Okay, they might spill to the right, to the left. Also, you can control the shape of this shovel. Right now, it's a straight shovel. You can think about that if the shovel would be slanted, then you're actually controlling the uncertainty, saying, okay, all of them will actually move forward and to the right. So sometimes that's a better way to do it. So we started doing this a while ago, and we started with pretty simple algorithms. So first of all, this is the mobile robot. Like I showed before, we quickly cheated and said, okay, let's miniaturize this and work on a mobile arm to actually mimic these outside robots. And we started thinking about these simple algorithms to do this push manipulation. Okay, we have so we kept on working on the problem, seeing how the simulations are, like we all know, they're not that good, they're pretty slow. Started working on how do you actually find simple models to see and to estimate where these rocks will be, depending on the path you're pushing it, depending on the density of the pushes and so on. Lilach recently did some work here, and she started doing the classic Monte Carlo tree search MCTS to do this. And recently she started, Recently she started working on going further into MCTS and actually using AlphaZero to actually have a dual offline learning and online planning with some learned networks for it. Some initial results you can see in her poster as well. We had Neil will show you, although this is kind of cheating, he's not using the two robots right now. He does want to use that later, but he is using, or he's planning on how to use multi robots to do this planning. And it's part of his ideas that he got pretty far with the algorithm and simulation is doing what he calls highways. So it's actually a squeeze function of reducing the uncertainties in order to get to a place where you know that most of the aggregates are, and then doing another push to actually push all of them forward. If you have different sparse aggregates around, you first of all push them into main highways, and then you go on the highway and you push them. And you can see in Neil's talk a bit more about that. Yalon, who is not here, couldn't come today. Here we actually went, like a lot of us, we started using LLMs, VLMs, and VLAs. Right now, we're using VLMs to actually ask agents in specific ways and training them in specific ways. What should, given a specific scene, given the model of how much spillage will be for each shovel, what should the typical path be? And this is one of the results from recent days. We have these aggregates here. We want to put them into this shape on the simulator, and these are the paths which are not optimal. They're actually redundant, but these are the paths. And the interesting thing here is that the VLM actually did pick the angled shovels in order to reduce the uncertainty in the side, but actually increase the uncertainty here, and then you actually do the push at the end to actually push it forward. So some interesting new results that we're starting to see with the newer model. These are some open questions to kind of get the feel of some things that we're doing. We have some other work, again, not clicking. And this is probably the best if somebody might be interested in this, is to talk to Federico in the audience. Very interesting project related to beavers, real beavers. Okay, it's collaboration work with Professor Kennedy, who was a postdoc in my lab, now a professor at Harvard University, where we're looking at get some bio inspiration from the way beavers work, and these really quickly. It's a very short teaser. These are some of the trails that beavers actually build throughout the year. We're trying to mimic this and to see what are the local controllers for us as roboticists doing the planning of multi-agent systems. What are the local sensing and control abilities that will recreate these types of quite almost optimal structures in order to actually move food around. So in a way, we're trying to see two things. What are the beavers doing in order to actually modify the landscape? Others and our collaborators are also looking at what are the benefits to the environment by doing these structures. Okay, so this is an interesting, very initial project, although we've been working on it for quite about a year now. We're starting having students asking more specific questions, trying to answer some interesting questions that arose from this thing. Quite different than what we typically did, but it actually formed things that we worked on multi-agent systems, and suddenly it fit in this project. So to kind of finalize, first of all, for prospective students who might fit my lab, first of all, people wanting to do algorithm design together with typically the students coming wanting to do real-life systems with physical or mechanical actually hardware to work on, and are interested in real-world applications. And not specific for my lab, but just general tips that I typically give students coming and looking for professors and labs and so on. I usually tell them three things here. First of all, I tell them to go and visit the lab. Okay, so meeting the students, asking the students what is the type of environment. So there isn't a good and bad, the way that I see it. There are different types of advisors, and sometimes it will fit students, sometimes it will not. So actually talking to the students, seeing how the lab works is usually the first tip I give. Together with talking to the students and taking professors' courses. A lot of times when you come as a student, when you come to a professor after you took a specialized course, that helps. And if you can impress them, that's even better. That can help the first start of this process.